Um, Come in. Yeah, hi, I'm Jan, and as already said, I'm today talking about making music with JavaScript and Gamepads. And I had this talk at another conference in Berlin, and if you've attended that one, the Reject.js, there's not much new today. There are some nice little features today. But anyways, so I got the inspiration for this talk from another guy who talked at the JSConf EU last year. It was Stuart Memo, and he was talking about how JavaScript is the new punk rock. And it was, if you haven't checked it out, that presentation is so awesome. And he inspired me so much. So what can you expect today? So first, I'm going to give you an introduction to the Web Audio API. So there's some coding involved. And then afterwards, I will talk about the Gamepad API. And then finally, I will show you how to combine them and how awesome things you can build together with them. But what is the Web Audio API? So it's an API that's very low-level access to everything audio. Like you can create sounds from waves, you can manipulate sounds with filters, and you can time sounds precisely, which is very important. And before the Web Audio API, timing was really, really, really bad in JavaScript. And there's tons of other cool stuff I will not talk about today, like spatial audio. If you have like a game, you can do 3D audio with that API in 10 lines of code. And I will not talk about that though. But let's all go back a step. And what is sound? So just to bring us all to the same level, sound is a mechanical wave that is an oscillation of pressure transmitted through some medium, like, for example, air or water, and it's composed of frequency within the range of hearing. So what it means is, if I stomp my feet on the ground, there's a wave created, it goes through the air into your ear, and if it's the right frequency, you can hear it. But what does it look like? Basically a wave. You can really, like, this is a speaker, and it's playing a 61 hertz sound, and this is, you can really see the wave in the speaker itself. So talking about it is nice, but let's do it. So our first web audio example here. So first what you have to do is create a context. That's very similar to the Canvas API, if you've used that one before. It's where you create all your stuff that you will build afterwards. So from that context, we create an oscillator. An oscillator is something that can create waves. And we say that oscillator should have the type 0, which means it's a sine wave. There are several forms of waves. And then we tell the oscillator that it will have a frequency of 22 kilohertz. And then we take the oscillator and connect it to the destination. And the destination now means the speakers, generally. And then we tell the oscillator to start, so to play the sound. But there's one problem with this code. Who spots the biological error in this one? Anyone? You? Yeah, right. So 22 kilohertz, we can't hear. So I will now play 22 kilohertz. And if there are any cats in here, they might leave the room now. It might hurt. So you will not hear anything. I clicked it. That's it. Damn it. No cats. We're good. But we can play it from a range selector, for example. It might not sound good now, but that's how you create sounds, very basically. That's a very low frequency, and then we can go up and go back. And as I said, there are different kinds of waves. For example, there's a square wave or a triangle wave. They all sound really awful, but I will play it anyways. So this is a triangle wave. And this is almost dubsteppy if you go back. Anyways. But that's the most basic way how you create sounds. But that's not as awesome as we can get. So let's play a sound from a file. And for example, let's play Get Lucky, which is a very famous song. And playing sounds in the Web Audio API is something that's really easy to do if you know Ajax, because it's just an Ajax request. You request the file, of course asynchronously. You say it's an array buffer what you get back, and then on load you call a function, it's called process file. which looks like this. So we still have the context. So this is in the processing function. So we have to decode the audio data that comes back, because we need to first decode it so we can use it in the web audio API. Then you pass a success parameter, you get the buffer, and then you save it. Or if something goes wrong, you might do something better than just logging it. So now let's play it. We loaded it from the server, and now again we create a buffer source from the context, which is a node like an oscillator. And then we tell it that it should use the buffer from the song buffer we just got. We connect the source node to the speakers, and then we say start. So let's try this out. Let's play Get Lucky from Daft Punk.
This song is not available in your country. Please go to your local GMA office. They will tell you why.
Okay. Yeah. Sadly, we're in Germany, so we're not allowed to play the song. But I have another one. So loading another one and playing it now. It's much nicer. And this is now loaded from the local web server, so it was really, really fast. It's by that artist. He raps about computer science. It's really nice, you can check it out. Anyways. Elaborate, thanks. So that's how you play songs. Now let's do something with the songs, like filtering it. And filtering means that we change the output by manipulating the frequency spectrum. And we're very lucky, so most basic filters are already implemented in the web audio API. So we can use them all, but also we can create custom filters very, very easily. It's very unstable, but it's easy if it works. So let's create a filter. Again, from the context, we create a filter, and then we tell the filter what kind of filter it is. In this case, it's a low-pass filter, which means it only lets lower frequencies through. So we cut out all the high frequencies, and we say 100 hertz. And then what we do then is we have our song, we connect it to the filter, and then the filter we connect to the destination, so to say, the speakers. So we have a setup like this. It's very easy node graph, and this is how the web audio API in general works. It's basically a node graph. So let's do this. It's a low pass filter now, and should only let through very low values. Let's see. If we go up, we have the higher values, and then the other way around. Only the high values. That's very easy to do and already implemented. So now let's talk about timing. Timing is key. When you're in a band and if you have a complex setup on a stage, you will have many delays, and it's very hard for professional musicians to adapt to it, but they are able to do it. And now imagine if you had a band that would rely on set timeout. That would be really awful because it's so off the key. So we have set timeout and request animation frame, but it really sucks because we need to do many many offset calculations, and it's it's so inaccurate. It's not usable for audio things. So timing in web audio is something completely different. So timing is relative to the current context. So the context always has a value, current time, which you can use to time things. So for example, let's start a buffer, like for example the song, in 2 seconds. So we already know the start method, and we can pass a parameter when it should start. And this is the current time, like now, plus 2, which means in 2 seconds. We're calculating everything in seconds here. And the start method is actually even more awesome because we can say when, you can define an offset, and you can say how long you want to play the buffer. And that's very precise timing with just 3 parameters, which we wouldn't have before. So let's try this out. So let's It will now wait 2 seconds and then play a song. Click. Yeah. Same goes for the stop method. I will stop in 2 seconds so we can listen to the song a bit more. Almost. And also we can skip to our most favorite part of the song with the offset.
Never gonna give you up, never gonna let you down, never gonna run around.
Nice. Okay, this is how timing is done in web audio. It's just you tell it when to start, and the system makes sure that it's started at that precise moment in time. I had that. But you can also do one more, like many more awesome things, but you can also define future values. For example, if on a set a value at a time. So timing is not just for starting and buffering, it's also for values. So for example, if you have a node and we want to set the gain value of a node, gain is something like the volume, we can say set value at time, so we set it to .2 in 5 seconds, and we don't need set timeout. Again, we can also use linear ramp to value at time, my most favorite method name. Set it to 0 in 5 seconds, but it makes an interpolation in between, a very smooth one. This one is linear, but you also have biquad and everything. So let's try this out. So we will set the gain to a lower value in 5 seconds. Didn't do anything. That was just a song. So let me show you some demos. What you want to do is when you get started with the Web Audio API, it's kind of the hello world of the Web Audio API is you want to build a drum machine. So you can set the bass, boom, and the kick, the snare. It's very good. Set the BPM. I prepared some that are really nice. So for example, very, very basic. And then let's add some variation. Yeah, totally do it in a band now. Then we have a hip hop beat, lower BPM, more bass, more kicks. And now I have a challenge for you. So the next one is taken from a song, which is one of my most favorite songs. And the person who guesses it right will get a beer for free at the after party. Oh, wait, they are for free, right? Okay, later in the evening you will get a beer for free. If you guess it right. It's not that easy, so let's try that. Not a hip hop song. The Deftones, right? You get a beer. So this is the original one. But that's it. So I would, if I have time afterwards, I will show you more demos because people have done such amazingly good things with the Web Audio API already. But I'm not here to talk only about Web Audio, but also about gamepads and gaming. So we are in a time now where more and more complex games are written in JavaScript with Canvas, WebGL, and but we still control the games with WASD, arrows, mouse, and keys. And it's very old-fashioned. It doesn't fit any game you want to play. So we have a problem that all the controls we have here, they are digital values. It's either on or off. And we don't have analog values as we would have them here with normal gamepads, which are more precise. Wouldn't it be nice to use gamepads in the browser? Yay! There's a gamepad API now, so you can use all your favorite gamepads in your browser. Nice. This is how you do it. So you request the gamepads from the navigator. It's an array. So let's select the first one. And you can read out the values by just accessing the buttons array of that gamepad. And then the first one will be the first button, and you get back a digital value again, which is like if I press A, it's 1. If it's not pressed, it's 0. Very easy. But that's only digital again. So we also have the access property, which gives us all the access that are available on this gamepad. And this now has analog values. So the first axis has a value of something. Yeah, but if I have a gamepad and like button 17 is 1, what the fuck does it mean? I have no clue, because which one is 17? Of course, it's standardized. Let me zoom in a bit. So for example, if I press this button, the API makes sure that it's always button number 12 that you've pressed. Yeah, I know you can see you're all excited about that. But that's how you have to do it. But did you notice something? There's something really odd when you, like JavaScript developers should maybe see it. If you look at the code again, how do we read out the values? Is it anything? You know it, you know. Right, there's no loop, but we need to use a loop, and it's not event-driven. Like what? With JavaScript developers, we're used to on-click and something. It's not event-driven because it's designed for usage in games, and games normally have an update loop where you get the controller state and everything, and you poll the gamepad states. Yay, we're back at request animation frame. Awesome. No. There might be events added to the API in future, but it's under heavy development, so we don't know. I think Firefox already has some events for it, but for now we don't. So, but let's play something. Well, I play something. So there's this doodle, and you might have seen it last year. And what many people didn't know, you can use it with the keyboard, but you can also, and I'm really bad at this, use it with the gamepad. So if I do it like this, I can run and then jump. Oh yeah, I'm so good at this. Just joking. No. Yeah, new world record. No, it's really hard. Yay! So, okay. But now, how do we combine the APIs, like the web audio API and the gamepad API? Like the easiest thing we could do is like check the gamepad state and say, if button A is pressed, play that sound. And I can do this. Let me think about it. I got a demo here. You won't see it, but I'm now playing this. You can do it like this, and this is very. Do you know the song? Yeah, I hope so. Yeah, but no. Let's talk about gamepads again for a second, because what exactly qualifies as a gamepad? Like this, of course, but I came up with this. If it has a button, it's a gamepad. It's of course it's duck typing, but what it means is this is a gamepad as well, and we can use it. And whoa, what's this? I brought one, and I made a demo with it, and I hope it works. So, as I said, the APIs are unstable, and I'm not a really good guitar player. I didn't say that, but you might assume it. And I hope it works today. Just bear with me then, if it doesn't. Wait. Using number 1. Okay. What you see here is the 4 buttons that I have here. Like I have 5, but this one's broken. And I will now use this guitar to play a very famous song. There's no beat challenge on this one because it's super easy. And if you don't know it, oh, I don't know. You all know it. Okay, you will. Okay, so. Okay. It really sucks to just play guitar. So I brought my virtual a drummer, and it's like this. Oh, sorry. Next one. Yay! That's it. If you have time afterwards and you want to play, just ask me. It's really fun. Even my flatmates wanted to play. I have to get rid of this one now. So that's a really easy demo, and I think it really rocks, and it's so easy to use. But this is also a gamepad. Oof. Of course, I brought it here. So what this is, it's the DJ Hero turntable, and there are a few people who know this game. I don't know why, because it kicks ass. It's basically like Guitar Hero with the DJ turntable, and it has this spinning wheel that like all the cool DJs use. You have a knob here, or I can show it here. You have a button here, then you have a knob here, and then you have a fader here, some buttons here, and I made a demo. So I'm not a good guitar player, but I'm an even worse DJ. So yeah, I started DJing the last time I had this talk, so the second time now. This is number 1 again. I hope it works. So this is a visualization for you now. You can see that I can, with the fader, I can adjust the volume here. The filter down there, you will see I will use it in the song, and the queuing, something I will explain now. And I hope everything works now. So let me just hit it up. No, I did it wrong. You might know the song. Again, no challenge. So, what I did here now, you can see the cue is fading, and queuing is something that DJs use to take parts of a song and loop it all over again. So what I did is I pressed the cue button, then it started recording the part, and then I press it again, and then it will have the end of the cue, and then we'll just loop over it forever. Like, it's one of the best parts of that song, of course. And if I press it again now, it will remove the cue and it will play as normal. I will mix a bit more. Let's add some bass. Wait a second. So what I can do now with the filter is, and go back again. Like the most basic filter you can use as a DJ, just a high pass filter. And there are some more things I can do with this thing here, but I have to wait. So let's cue something again. So this is how a techno DJ would do it. You have this, and then you would do some really weird stuff with it, but I'm not a techno DJ. I'm playing Daft Punk. And so what I try to do is you have a high value in the filter and then a low volume. Oh, wait a second, I have to do this now. So we have the turntable, let's use it. So this is how you would fade out a song then. So that's it. That's how you DJ with JavaScript. Yeah, what I tried to do was something bad. Like you have the filter in a high pitch, and then you set the volume low, and then when the song starts to play again, you remove the filter, you turn up the volume, the crowd is going, yay! It didn't work out. Yeah. Anyways. So let's go on. So there are some problems I have with the APIs. Like the demos are fine, but they're still very unstable, as I said. And if you're doing fancy stuff like custom filters and working on the bits and bytes and everything, you might crash your browser. Happens. And there's no such thing as a negative play rate. Like when I used the turntable here, I gave the song a lower playback rate. Like a playback rate of 1 is you play it at normal speed, and then if you go lower, it plays slower. But you can't go negative. So what I would need this for is like for scratching on a turntable, you need a negative play rate to play it backwards. But we don't have it yet in the API, and that's really a bummer. So no DJJS for now, like no real DJJS. Like if I play a song, I don't like it's called a buffer node. I play a song like the Get Lucky. I never know at what time I am in the buffer, and that really annoys me because now again need to calculate stuff, and there's only one destination for now. So imagine you're a DJ and you have 2 turntables. You play the one song here, and normally what you do is you have the other song here, and you pre-listen to it and you adjust it to fade over or have a nice effect. You do it with 2 sound cards. Yeah, but we can't do that because we can only talk to one like the context of the .destination is the main sound card. So we would have like DJJS, but like blind DJJS because you can't pre-listen to the other songs. So you have to like do it on the fly. Maybe it works. You never know. I hope they will implement that. And yeah, there are some problems with the Gamepad API. Like it's very unstable, and Chrome and Firefox are not compatible. Like woohoo! I want events, and I want to talk to the gamepad because now what we do is we read it. But this has awesome Rumble features, and this one has LEDs here, and I want to set them with JavaScript so I can have a more nicer experience for the user. And yeah, sometimes it's unstable, and I can't connect the gamepads. It worked out today, yay! And so some of the Guitar Hero drum kits, like there are many of them. Some of them don't work, and one of them, like I had one and it broke, so otherwise we would have like Rock Band jazz here now, like a drummer, a DJ, and then maybe a singer from the crowd. But no, like they should all support all the drum kits. So let's wrap it up. So Web Audio API is like incredibly powerful. You can do so many things with it. It gives us such a low level, though easy to use access to all audio things, and the Gamepad API is like super easy to use, and when you combine them, you can play like real fake instruments, and I can see like things like GarageBand.js. Do you know GarageBand? It's a music production tool for the Mac, and I can see that happen in the browser in the near future. And in fact, I'm working on it. But also, what I want to see is there's this band. Wow. They're using only digital instruments and inputs in their performances. Like they're not a DJ band, like turning knobs and everything, but they actually perform stuff in front of the crowd. Like they don't have normal instruments, but these are all electric drums and pads they can click on. And I think with what we have right now, what will come up in the future with MIDI support in browsers, we can, I don't know, what I want to see is, I want to see the glitch mob perform in their browsers. That would be like the most awesome thing next year. Somebody has to do it. It isn't me. Okay, so that's it. I'm Jan. Find me on Twitter at the DevTone. I'm on GitHub, Jan Monschke, and this is my website. And thanks for your attention. Yeah, and I think do we have time for some more questions? Oh, I rushed through it. Yes, it is. Well, you can set it if you. It's very precise. If you can say, oh, you can say in a thousands of. Oh, thanks. Ooh. You can say play it in a tenth of a second or a thousandth of a second. So that's easy to do. It's not just integers, luckily. That would be really bad. Yes.
What is the state of MIDI support?
It's a weird state. It's available in Chrome Canary on Mac, and only on Mac. Yeah, I think it's because I don't know if Windows has a nice MIDI API. I don't know. Yeah, you. I know. I can't tell you. I would love to see OSC, like
The better MIDI.
yeah. OSC is like MIDI 2.0 plus 1 and more awesome, basically. Yeah, but like all the instruments are still using, like most of the instruments can use MIDI and not OSC. I hope OSC will be supported though. Yeah.
Can it support microphone input? For example?
Yes, I didn't show that today, but there are some demos, and we have plenty of time left. And if you want to see that, I have some demos. Yeah. Live input. Go away. Hello? Can you hear that? That might break now. That happens. Hello? I said allow. Hello? Anyways, so yes, you can do that. And what Stuart Memo did in his song, in his talk at the JSConf. I hope the internet's fast enough. There's some drum demo.
So this allows us to take.
And then blah, get user media. Yeah, oh, damn it. You can use get user media to get all the media. So what he did, he connected his guitar to his computer, and then he made it available in his browser with the get user media. Then he has all the effects here, and then he stood in front of 500 people and just playing his guitar with JavaScript sound. I'm not sure when it starts.
So we getting that? Is there something there?
Yeah,
it's quite quiet.
yeah, that's what he did.
So this is a
Blah,
guitar.
blah, blah. Anyways, yes, you can do that. You can do it with video and audio. Yes. You.
In the beginning, when you were playing the song,
E3. Does that song play as it is downloaded, or you have to download all of it? beforehand?
There are some nodes, like what I was using here is the buffer source, which there's a streaming buffer source basically that can do that. So it downloads the song and maybe a live input, and then you can manipulate that song or play it, whatever you want to do with it.
and how can you control that?
I don't know. I haven't used it yet. So the API is really easy to read. So if you want to get to know the Web Audio API by heart, I suggest you just read it. Oh no, that's a book. Whatever. It's really easy to read, and there are so many explanations. Yeah. Anything? No. Yeah, what we could do is definitely to hook Node.js to a system process and like interface the the web audio API in a module, and I'm not sure if somebody did that, but it's of course not part of V8.
If I remember correctly, there is binding for OpenAL or something, which is API compatible with the audio API.
Perfect.
So you can kind of use the same when you run the browser to run Node.js, but it's really like the worst part.
Yeah, I imagine that. Like the web audio API is like oof, and if you have like yes. Anything else? Oh. So thanks.
All right, thank you very much. And also you get
Thank you. Thank you. I haven't tried it out. Would be really nice. So what you can say is, can I use audio? And what you see here is you have iOS Safari, and it's been supported since version 4 of the iOS Safari, and the Android browser supports it since then. In a web view, I don't know. Maybe.
Since this really, since the kit
Yeah, right. 4.4, okay.
Chrome, so at least for now, that should work on the new Android. No?
yeah, I just read about Android KitKat and has WebView is running for KitKat. You don't have web audio for that.
No.
That's really
Sad. So you have to build a web app.
But I think
And
that's
not an
just the audio tag and not the web audio API.
Yeah, sorry. Oh, damn it.
Just minus API.
Yeah, damn it. Minus API. Yeah. Still, it's supported. You can see. This is the iOS WebKit. Oh, I thought they supported it. Anyways, you can use it on your iPhone.
Nobody has.
Oh, come for Android.
And iPad. iPad Air.
Come for Android.
Android is the
Ooh. There you go.
Who uses the default browser on Android anyway?
My mom.
A lot of people.
For Samsung users.
So I guess you can ask more questions if you want to stay, but just so you know, we now have our bigger lunch break until 2 p.m. Lunch is